So first of all, remember our whole goal is to come up with how many outcomes there are and how many potential outcomes there are. So let's talk about our potential outcomes. So when I deal you 5 cards, you start with 52 cards and I'm giving you 5 of them. The order in which I give them to you doesn't matter. Because if you have the 10 of hearts first versus the 10 of hearts last, it doesn't matter. Whenever you're playing cards, you organize them how you want to. So order doesn't matter. And so it's 52, choose 5 cards. That is the number of possible outcomes. So anytime you're playing with 5 cards, it's always going to be our permutation, where we have 52. Pick 5. I'm sorry, it's not a permutation, it's a combination. I just said order doesn't matter. I don't know why I said it and then I didn't do it. All right, and that would be 52 factorial all over 47 there's a 47 factorial times 5 factorial, which is actually going to come out to a big old millions, 2 million, something, equals 2,598,960. All right, now the big thing about being an ace, king, queen, jack, and 10 of hearts, that is 5 cards. There's only one king of hearts. There's only one ace of hearts. There's only one queen of hearts. There's only one jack of hearts, 10 of hearts. So there's only one hand that has all 5 of those in. So your total outcomes are 1 over your total potential would be that 2,598,960, and that would be your probability of that hand. The 1? Yeah. The 1 came from the fact there's only one hand that has that in. Because there's only one 10 of hearts, one jack of hearts, one queen of hearts, one king of hearts, and one ace of hearts.
Oh, I thought it was saying like, oh yeah. I thought it was saying like an ace, a king, a queen, a jack, and then the 10 of hearts.
Oh, no, they're all hearts. Yeah. I got you. Otherwise, it would change the answer. Yeah. Yes?
10D.
Oh. Yeah, 10D, yeah. Other questions?
I have that one too.
Cool. Other questions?
I have 10D as well.
Cool. Other questions? We're going to answer 10D in just a second. It'll be part of this lesson. Mary, I'm not diverting to the question. I'm just going to answer it in the lesson.
For 12 and 13, where did you get the 8 from? Like when you're multiplying?
Where did I get the 8 from?
Yeah. Like in the institute, like I understood how you got like 1 over 11, then you multiplied it by 8 over 11, and then repeat.
Because it says, and then a number less than 12. There are 8 numbers that are less than 12. There's 11, 10, 9, 8, 7, 6, 5, 4. There are 8 numbers less than that. That's where the 8 came from. Yep. On the surface, it almost looks like I'm saying, what's the probability of drawing a 14 and then a 12? If you write really quickly, but it says less than. Other questions? That's it? None? As long as Ross says none, then we're good. All right. Oh, Mary. Oh, the Ross check didn't check out this time. Mary.
8D.
Yeah.
I got 1/4 as opposed to 3/4.
So it says at most 1 head, right? So at most you can only get 1 head. What's the only time that you'd get more than 1 head? Is if you had both being heads. That's only 1 occurrence out of 4 that. So let's just write them all out. So we could go heads. Maybe I shouldn't do that. I will do that. We could go heads, tails. We could go tails, heads, and we could go tails, tails. All right, these are our possible outcomes. It's 3/4 because this one has 1 head, 0 heads. The only one that doesn't work is that one, so it's 3 out of 4. And we'll kind of answer that one a little bit today too. Because if your whole goal to answering a question is writing them all out, it might not be successful considering, like, let's say I had 10 coins. And we say at least 1 head. That's going to make it a lot more complicated, and you don't want to draw out 10 heads. So we'll talk about that today. Other questions from the homework, though? Okay, then we'll go through today's lesson. Today's lesson is increasing our potential for coming up with probabilities. And that is expanding it to exclusive and inclusive events. These are going to be events tied together with the word or. On Friday, we had the word and. We said, what's the probability of rolling a 2 and a 3, which means I was rolling 2 dice. Today, we're going to talk about or. And before I get to anything, that upside down U is the word for, oh, that's the correct side up U. The U, it is awkward. Well, I was looking at it upside down, so. Okay, the union symbol, which looks like a U, it stands for or. So, let's talk about mutually exclusive. First of all, these are two things that cannot occur at the same time. It's black and white. It's either one way or the other way. It can't be both. My example here was rolling a 2 or a 3 on a die. It is impossible to roll a die and it come up to 2 and 3 at the same time. It's either going to be a 2 or it's going to be a 3. In this case, what you're going to do is you're going to add the probability of rolling a 2 and you're going to add it to the probability of rolling a 3. So it's going to be a strict addition when you have just an or and they're mutually exclusive. Mutually inclusive. This is where we're going to have gray area. That both can happen at the exact same time. So my example here was, what's the probability of picking a king or a heart? There is overlap between those two, cards. We could have a king of hearts. The king of hearts is an overlap. So let's talk about what we need to do then. So it looks almost the same as our mutually exclusive. I'm going to take the probability of pulling a king, and I'm going to add the probability of getting a heart. Here's the problem. There's too many additions there. And that is because in this column, I'm accounting for the probability of pulling a king of hearts. And in this one, I'm calculating the probability of doing a king of hearts. So I calculated the king of hearts twice. You cannot calculate it twice, so you have to subtract one of them away. So what this is calculating the probability of a king plus the hearts, and you're going to subtract that extra one by subtracting away the overlap. That way you're only accounting for one king of hearts. This right here, if I cover up the subtraction, is looking like you have 2 king of hearts in one deck. You do not. So you have to subtract that one away to get that. So when it's an inclusive event, you're going to add the 2 events and subtract any overlap. It's going to be critical that if I put an or in a problem that you have to immediately go, is it exclusive or is it inclusive? That's going to be your big thing with the or statement. So let's look at our 2 examples. Our first one says, find the probability of drawing a king or a queen. So as soon as you say or, you have to think, is it inclusive or exclusive? Is king or a queen inclusive or exclusive? Ross.
Exclusive.
It is exclusive. No, that's an N. It's exclusive because either it's a king or it's a queen. A king or queen. There is no overlap. There is no king-queen in the deck. All right, if it's exclusive, all you need to do is take the probability of a king and add it to probability of getting a queen. So probability of a king, there are 4 kings in a standard deck, so it'd be 4 over 52. The probability of pulling a queen is also, there are 4 queens out of 52 cards. Note, there is no pulling it out and replacing it. This is saying, in one pull, what's the probability of being a king or a queen? Now, because it's exclusive and it's an or statement, we are going to add. And so that's going to equal 8 over 52. 4 goes into both of those. We'll have 2 over, 13. Yep. You have a 2 in 13 chance of pulling a king or a queen. Yes?
Wait, so if it doesn't say anything about, like, cards aren't replaced, you just assume that they're replaced?
Well, no, we're not replacing anything. This is saying if I pull out one card, what's the probability of that card I'm holding being a king or a queen? I'm not pulling out 2 cards. That's why I said specifically an or statement isn't pulling 2 things. It's pulling one thing, and it could be possibly 2 things. When I turn it around, what's the probability of being a king or a queen? I'm not pulling another card. What was that?
They're separate events?
They're not. It's the same event. We're just expanding it. So I expanded from. So one event would be pulling a king. Like I pull a card. What's the probability of being a king? I'm just adding. Well, what if it's a queen?
Okay.
Like let's say you win if it's a king or queen. You want to know what the probability of getting either one of them is. Okay. But this makes sense because there are 4 kings. There's 4 queens. That means there's 8 potential winners out of 52, which is what we got, 8 over 52. All right, our next one is find the probability of drawing a king or a spade. Is that inclusive or exclusive? Without yelling out the answer.
In.
No? Inclusive.
Wait, why? There is an or.
There is an or.
Because the king of spades. They're two, no,
Good
because it could occur a card in or in suit.
Explain.
It's inclusive. So or branches into 2 different realms. Either exclusive or inclusive.
Yes.
Exclusive happens if there is no overlap. Inclusive happens if there is an overlap. And there is an overlap because there is a king of spades.
Oh. I hate these. These are about cards.
Do we have like
Wait, no, that's just like common sense.
Yeah, will you tell us?
Don't change the dragon.
Okay, mutually,
I don't
mutually
know about it.
exclusive is
Okay, just since there's a king of spades, it's got a foot in both camps. That's why it's inclusive. So now when I calculate the probability, I'm going to do the probability of pulling a king plus the probability of pulling a spade. And I'm going to subtract the overlap. So that's the probability of pulling a king of spades. There are 4 kings in a deck, so we'll have 4 divided by 52. The probability of spades, remember there are 4 suits. So it's 1 out of 4, but it really is 13 over 52, so we can have the same. I said it, but I didn't write it. It's 13 over 52, because that is 1/4 of 52, just so we have the same base. All right, now we're going to subtract away how many king of spades there are. There's only 1 of each suit, so there's only 1 king of spades, so we're going to subtract 1 over 52. Well, that's going to result in 16, bless you, over 52. 4 goes into 16. 4 also goes into 52, so it's going to be 4 over 13. You have a 4 over 13 chance of pulling a king or a spade. Is that a little clearer on cards? Maybe look at a deck online or something. It's like the most used probability. All right, our next one. Our next problem has percentages, and that's fine. In a group of students, 60% are commuters, 50% are female, and 30% are female commuters. Find the probability that a randomly selected student is female or a commuter. Or means I have to determine if it's exclusive or inclusive. What is this one? Is it exclusive or inclusive? It is inclusive. It is inclusive because there is overlap. There are female commuters. That means it has a foot in both camps. It is both items I'm looking for. So if it's inclusive, we're going to do a probability plus a probability minus a probability. So we're going to go the probability that is female plus the probability that person is a commuter minus any overlap. So that's minus the probability of a female commuter, an FC as they go by all the time. Very common terminology. Or I'm just too lazy to write female commuter. One of the two. All right, probability of it being a female is 50%. Plus the probability of being a commuter would be 60%. And you know you made a mistake if you stopped there. Because 50 plus 60 is 110, doesn't work. What do I have to do next?
Well, okay, so it wouldn't be 50% female, it'd be like, whatever, 50 out of 60 is out of 100.
Oh, you're saying turn into fractions.
And wait,
We're okay with what we're doing, yeah.
Don't you just subtract 30?
Yeah, I'm just going to subtract 30. Which is going to equal 80%. What I think Mark was saying is, hey, we could turn these in fractions. Like I said, percents work. A lot of times people like putting things in fractions. So we could say 50% is 50 over 100, or 5 over 10, plus 6 over 10, minus 3 over 10 would equal 8 over 10. Either one would be a good answer. All right, be careful on this next one because it changes depending on this number. And we'll talk about what I mean in just a second. So it says, when a pair of dice is rolled, find the probability of observing a sum of 12, or at least one die shows a 2. So once again, we have that or statement, which means I have to decide if it's inclusive or exclusive. Ross?
Exclusive.
It is exclusive. It's going to be exclusive. There is no sum of 12 that has a 2 in it. There is no sum of 12 that has a 2 in it. So it's exclusive. Maybe I shouldn't put since. There is no sum that has 2 in it. Because if I look at the only one that adds up to 12 would be 6 plus 6. That's our 12. There is no 2 in it. So now if we look at the ones that we roll a 2 in, so it's exclusive. So let's do our probability first. So when it's exclusive, we do the probability that we roll a 2 plus the probability that we get a sum of 12. Well, I already know the sum of 12. That's just 1 out of 36. 6 times 6 is 36. We have 36 possibilities. For all the ones that have at least one die being a 2, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Be careful and don't count 12. So let me circle those. It would be all of these plus all of these. Now this is a really good example of why we get rid of things when we're doing mutually inclusive. Is if I'd count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I double counted something. That's why when they're inclusive, we eliminate something. So this is actually going to be 11 over 36. Plus that would be 12 over 36, which is going to be 12 goes into both of those, 1 over the trace. Now before we move on, I want to stick on this one. What if I would say the sum is 6? Would it still be exclusive if I said I'm looking for a sum of 6 instead of 12? Mark?
No,
No, why?
because there's sums of 2 in it.
Yes, there's sums of 2 of it. So if I said the sum equaled 6, you'd go, oh, 2 and 4 is overlap. You'd go 4 and 2 is overlap. So both of those would be ones that I'd have to eliminate when I added them together. So be careful on a problem like this because it depends on what the sum is. Don't just go, oh, the example in the homework said that was exclusive, so every kind of one of these is going to be exclusive. That isn't true. That isn't true. Just like maybe not every example like this is going to be inclusive. Maybe I'll say 60% are commuters, 50% are female, and 30% are train workers. none of that is necessarily inclusive. All right, before I get to this, let us go back to that question we had from the homework. A lot of people had questions on 10D. Is basically we have a bunch of marbles in a bag. We have 5 red, 3 yellow, and 4 blue. The D problem says at least 1 red. Well, here's the problem with at least 1 red is it's a bunch of or statements. Either the first one's red, or the second one's red, or they are both red. You would have to add all of those together and make sure you subtract out anything that's overlap. There is a much easier way to do a problem like this. It is called coming up with the complement. At least 1 red. There's only one case where there isn't at least 1 red in there, and that is if both of them aren't red. So that's what I did. I came up with a probability that I get no reds. So I said 7 over 12 would be my first one not being red, times 6 over 11 would be my second one not being red. That means I have a 42 over 132 chance, or 7 over 22 of neither of them being red. That means the flip side of it would be all the ones that would have a potential red. And so we'd have 15 over 22 would have at least 1 red. So once again, this is my sum of not getting any reds. So what this can be called is the complement would be how many could have at least 1 red. And that's what we're going to talk about right now. So we're going to talk about something called complements. Complements are, I have a 75% chance to finish this lesson. The complement to that would be I have 25% chance I won't finish this lesson. All right, it's just whatever the opposite is to get to your 100%. That is your complement. So a complement of event A are all outcomes that are not the event A. And this is called A prime. This is called A prime, or I guess A apostrophe, we would call it A prime. In some cases, finding the complement is much easier to do the calculations. In fact, there are times where it's the only way to calculate what we are doing. Real quick, I'm going to put a little equation right there. The probability of any event happening is going to be 1 minus the probability of the complement happening. That is just like what I said with my teaching. If I have a 75% chance of finishing the lesson, that means I have 100% minus that 75, which is 25% chance of not. That's what that 1 is. That 1 is 100%. All right, let's do this example. It says, throw 2 dice. What is the probability that 2 die are different? Let's do this by doing the complement first. So let's do the complement. And the complement's going to be the probability of A prime happening. The complement is, what is the probability of 2 die being different? The complement is going to be, what's the probability that they're both the same? Probability that they are the same. That's your complement. It's the complete opposite. So now I'm going to calculate the probability that they're both the same. Can someone tell me what's the probability of both my dice being the same if I rolled 2 dice? Yeah. It'd be 6 over 36. Because there are 6 occurrences of them being the same. We could have 1 and a 1. We could roll a 2 and a 2. We could roll a 3 and a 3. We could roll a 4 and 4, a 4 and 5, and all the way up to 6 and 6. So that means we have a 6 out of 36 chance of rolling the exact same. So now we can calculate the event. The event I'm looking for is the probability of A. That is the probability that they are both different. All right, to calculate that, we're just going to do 1 minus the complement. So 1 minus 6 over 36, which I would probably simplify to just 1 over 6, right? It's always just easier if I'm doing the subtraction just to do, that's 1 over 6. All right, 1 minus 1 over 6 is going to be 5 over 6. That is way easier than coming up with what's the probability of rolling a die, what's the probability the next one would be different, and going the opposite direction with it. All right, so that's 5 over 6. Our next one is the letters of the alphabet are written on 26 cards. 2 cards are chosen at random without replacement. What is the probability that at least one of them is a consonant? We're going to include y in our consonants because y can be either one depending on how you use it. All right, so y is going to be a consonant in this one. So we're looking for the probability that at least one of them is consonant. So we're going to first do the complement. The complement would be PA prime. Let's put that back like that, PA prime. Our complement for this one is going to be the probability that they're both vowels. What's the probability of the first card being a vowel? There are 5 vowels, A, E, I, O, U, and sometimes Y. But in this case, we're going to say it's a consonant. All right. There are 5 vowels. What's the chance of my first draw being a vowel? Mary. It'd be 5 over 26. What is the probability of my next card also being a vowel? Nora. 4 over 25 with a question mark? Or is it actually 25? Okay, you're good. Yep. Stupid story in that. I was on a test and I forgot how many letters there were in the alphabet. And I was using 27 the whole time. All right. So this is going to equal 20 over some big-ish number. 650. Which we can reduce down to 2 over 65. Remember, this is not what I want my answer to be. That is the complement. So how do I come up with my event then? The event I'm looking for is PA. Our PA is at least one consonant. At least one C. How do I come up with that then? If I know the complement's 2 over 65, how do I come up with the actual event? Bless you. Mark. 65 minus 2. Probably not that. I don't know why you're doing 65 minus 2. Ross?
1 minus 2 over 65.
Yeah, it'd be 1 minus 2 over 65. Or you can just use a little logic and just go, okay, the opposite is going to be, what, 63 over 65? It's whatever's left over. I think you knew what you were saying, though. You did 65 minus 2, so you'd get the top part. Yep. No, you were 100% right. I was looking for the 1 minus. You wouldn't have that wrong on a test or anything, but I just wanted to be clear that it's 1 minus. All right, questions on that? All right, the last thing we're going to talk about are odds. You hear odds all the time, like 62 to 3, or the sporting team has a 42 to 2 chance of winning, or so on and so forth. Well, when we're talking about odds, you're talking about odds in favor and odds against. Odds in favor of something happening is going to be the ratio of the probability of the event happening to the complement of that. The odds against are going to be the complement to the actual event happening. So real quick, what are the odds in favor and against of getting a sum of 5 when rolling a pair of dice? What are the odds against getting that sum? So the first thing we're going to do is, what's the probability of getting a sum of 5? Let's come up with that. Let's come up with the probability of getting a 5 as a sum. Now, you don't have to turn the page to see all those. You can actually do it in your head. Ask yourself, how many different combinations are there where 2 die add up to 5? Priya?
4.
There's 4. There's 4. There's a 1 and 4, which means you can do 4 and 1. There's a 2 and 3, and then there's a 3 and 2. The dice can, oh, they're all, no, they aren't. Those are 6. But, yes, so we're going to have 4 out of 36, which we can reduced down to 1 over 9, which means the complement, 8 prime, would equal 8 over 9. So the odds in favor are going to be 1 over 9 to 8 over 9. More than likely, if you're going to Vegas or something like that, they're going to write it as 1 to 8. So basically, I just multiplied everything by 9. So it's just 1 to 8. I'm okay with this on the quiz. This will be what I'm looking for on the quiz. Odds against would be 8 over 9 to 1 over 9. Once again, that could be said 8 to 1. Yes, Mary?
So basically, just to get the other one, just
Flip the two things, yes. So in favor is the event to its complement. The against is basically the complement to the original event. Realistically, what we're looking for is this is what I kind of call it a success to failure. I call this a success because I'm trying to roll 5 to failure. So that's why in favor would be success to failure, and this would be fail to success. What I want you to be clear about this one is when you're looking at odds, so say I have 1 over 9 to 8 over 9. There are actually 9 possible outcomes. You succeed once, and you fail 8 times. It's important to realize that 9 events, possible outcomes are happening here because that's what's going to happen here. It says the odds of hitting a single number in a roulette are 37 to 1 against you. What is the probability of winning in percent? All right, so first of all, let's look at this. So your success is going to be 1. That's your success. You're going to fail 37 times. So you have a total attempts, or total outcomes, equals 38. 38 possible outcomes where you're successful once and you fail 37 times. So when I'm looking for what's the probability of winning in percentages, you're going to take your successes and you're going to divide by your total possible outcomes. So it's going to be 1 over 38. Now, how many people do 1 divided by 37? Yeah, Mark.
I did it.
You did it?
Or I tried.
Oh, you tried it in the beginning, yes. How many people are going to do it on the quiz? Since it's only Wednesday, maybe less, but I'd say about 50% are going to do 1 divided by 37. It's on Wednesday. We have a quiz on Wednesday. Day after tomorrow. We just have a quiz on this and binomial expansion. All right, so that's 1 over 38. It does say to write it as a percent. This comes out to about 2.6%. Note, if you'd plugged in your calculator, it would not come out to 2.6. It would actually come out to 0.026, which you have to write as a percent. Don't be the one that writes 1 over 37. Make sure it's 1 over 38. It is success to fail or fail to success. Your possible outcomes are when you add them both together. All right, questions on any of that? All right.